Now, we've looked at how to do a variety of different programming tasks. Everything from breaking a problem down to smaller subsections with functions to making decisions and repeating a section of code. Now I want to look at one of the more difficult parts of programming, which is error detection. And there's three major types of errors that you're going to find in a standard program. The first is one that you see on a semi-regular basis, and it's called a syntax error. We've seen this early on. Maybe we misspelled something. We went to call the print function and we called it the pint function. Maybe we went to write if and our keys got a little bit switched around and we typed in fee instead. So those are syntax errors, and those are the easiest to find because it's breaking the syntax or the language structure of our programming language. And this can happen in any type of programming language. Those are relatively easy to solve because we find the problem and then we can go in and easily fix it. Now, the nice thing is a lot of times these are easy to fix because the language editor, whatever we're using, in our case, Visual Studio Code, a lot of times it will point out what the error is, and sometimes it'll even say, hey, did you mean, and give us an option. Visual Studio Code is notorious for giving us 2 or 3 potential fixes. Now, they don't always have a potential fix, but sometimes they do, and a lot of it has to depend upon your integrated development environment or IDE as to how that's going to help. The second type of error that we tend to run into is a logic error. And the easiest way to find those mistakes is to run our code, to practice it, to give it some sample data and see, do we get data that we expect? We've seen examples of this where maybe we did a less than and we were looking for a greater than symbol. That's actually a pretty easy one to make because if you're like me and you have a little bit of dyslexia, those symbols are easy to switch around, but they have 2 very different meanings. So the easiest way to find and fix those is running test code. Later on, if you go further in your computer science studies, you'll learn about unit tests and how unit tests can often help us find some of those problems. Now, the third type of error is much harder to find. And not only is it harder to find, it's harder to fix because we don't necessarily know what's going to happen. And these are referred to as runtime errors. And a runtime error means that your program's running, your logic is correct, but it receives some sort of data that was not expected. Let's give a quick example of this. So here's an example that we had from our previous module where we want to open up a data file and we want to print it out line by line. If I go and I run this, I can see all of my information. However, what happens if instead of saying data 02, I wrote data 2 in order to open? Okay, well, what's going to happen? Well, let me do a clear screen real quick, and I'm going to run this one more time. And notice that the computer's not smart enough to figure out that, oh, I meant data 02 for my file to open. It just says error, and it exits out with what's known as an exception. Exceptions occur during runtime, and it causes the program to either crash or exit out. And exceptions can occur for a variety of reasons. Now, when you work with files, it's not uncommon to run into runtime errors. That's because maybe a file has moved, or maybe the file has changed names, or maybe the file was deleted, or maybe the file is corrupted, or maybe the file is of a different version than you expect. In fact, the number of potential things that could have happened to that file, because it's outside of your program, you don't have control over it, means that those can be enormous amount of problems you can run into. And this is what we see here if we look at our terminal screen. We get a file not found error. No such file or directory. It's pretty straightforward. It lets us know what we're looking for. And a person who is on top of things, they can either look in my source code and fix it, or they can go to the file and fix it. However, that's not always the case. And maybe we're dealing with someone who's not technical, who doesn't run the source code. They just click on an icon on their desktop. They're expecting it to work. So what do we do? Well, this is where we get into something called exception handling. And exception handling is all about working with the exceptions or the cases that we hope don't occur but might occur inside a program and handling that problem. So let's see how we would solve a problem like this. Python, like most modern languages, has a built-in mechanism. It's called try, and then we're going to put our with block inside of that try. So when we do the try, it's going to go out and try this piece of code. But it knows that there may be a potential issue. So let's take a look at how we're going to solve this. And you'll notice that the try right now is underlined. That means there's an error. That means it's missing something. So every try has to have one extra part, and that is an except. Now, we can specify a specific type of exception. For example, the file not found error. And now we simply put a little print statement here. We're unable to find the file. If I go and run this, notice that instead of seeing this big block of technobabble that a non-technical person wouldn't understand, we get we were unable to find the file. Now, behind the scenes as a software developer, when I would write exceptions, I would have something that's very simple like this for my end user. But I might write to a log file with a lot more detailed information, such as the day and time it happened, what the file name was that I couldn't open, a wide variety of things like that. But this created a nice, simple way for me to display an easy message for my end user. This is not going to freak them out. And if you notice, the file exited correctly. It did not terminate abnormally. And what that means is if I had additional code afterwards, it would still run. Let's modify our main function just a little bit to see what that would look like. So here I am on line 8. Notice I am lined up with the same level as my try and except, so I'm still inside the main. And I'm just going to say we're exiting the main function. The whole point of this is just to prove that, hey, my program didn't crash. I caught the exception, I handled it inside the except, and then I continued running. Now, if we go and run this, notice we were unable to find the file, and notice it has a little piece of code afterwards. So that exception keeps us from crashing the program. It lets us provide a more user-friendly error, and then we go on. Now, we need to be careful that we don't need to do anything with that file afterwards, because that obviously is going to cause a problem. And that's the reason why it's nice to use that with that combines everything that we're doing inside that file, inside that block. It's all inside that try. So if something happened later on to the file, maybe we open it for reading and we try to write to it, etc., we can capture those errors as well. You might say, but wouldn't that produce a different type of error? Yes, it would. And so I can put in other exceptions. So I can say except, and notice that as I start to type, a file exists error automatically comes up as one of the potential issues I might run into. And I can see other errors that might occur if I go and start typing. Now, some of these I'd have to look inside of the Python language library to get. Some of them are going to be provided for me by Visual Studio Code. Some of them I'm going to find out just by example and practice. Now, if I want kind of a catch-all, I can simply use except. And except says I'm going to get every potential error. Okay, so if I say except and I don't give the error exception name that I'm looking for, this will work, and it's just a catch-all. So I can handle certain types of errors in specific ways, and then I can also have that general exception. Now you might go, well, should I just put a try except over everything? Well, probably not, because it does tend to slow our programs down a little bit, and we don't want to use a general exception over a huge block of code because that doesn't help us with figuring out where the error might occur. So instead, we want to look for things that are common problems that we might run into. So let's look at some samples of common errors that we might run into and how we're going to work with them. So we know that when we use the input command, we get a string from the user. So let's just put that into a variable. Let's say x equals 18, and notice I put that as a string. And then I'm going to try to say y equals x divided by 7. Print y. Okay, so here I have this information. If I go to run this, you're going to notice that it gives me a type error. This is a common runtime error that we're going to get, where we're not using the right data type to perform an operation. This is because Python is a semi-typeless language, I like to refer to it as. That is, it has types behind the scenes, but generally we don't define a variable and say, oh, by the way, you're a string, you're an integer, you're a float. We don't typically do that, and so we do often run into type errors. So this is a good exception to catch. I'm going to take out this catch-all. You'll see why in just a second. Let me give you another common error that you might see. This is a data conversion error. So you know to look for the type error. You want to say x equals, and then you get something from the user, and they just mistyped. They meant to type 18.8. They typed in 18.8.9, something like that. So I have this. Now let's say I want to convert this to a float. Okay. So I'm going to say y equals float x. If I go and run this, you'll notice I get an error. This is called a value error. The value that was passed to my float function was not a properly formatted number. I would also get this error if I tried to do an int. Okay, ints can't have a decimal place. Floats can't have 2 decimal places. You can kind of see how this works. So if we're trying to convert data from one type into another and it's an error, you might get a value error. So we can use these exceptions and we can add these in here. And on and on and on you go. So you can notice that we have multiple excepts working. Well, you could even do something if there were no errors. And this is called the else suite. And I'm simply going to put else. Okay, I'm going to take out my section that was supposed to generate the error. Going to clear my terminal screen, and now I'm going to run. I press sample. There were no errors running this code. Okay, so I can even have a else to say, hey, there were no errors, and then do something. So we have a lot of flexibility that not all languages provide. Now, most modern languages do allow for exception handling and error detection like this. They may not use the exact same language. Java, for example, uses the try-catch, but the same basic idea does work, including the allowance to handle multiple types of exceptions. Now, Python is a little unique in allowing for the else suite because not everyone has that. But there is one more block that Python has that most languages do have. I want to go through that real quick. And that is called the finally. And finally says, I'm going to execute this whether there was an error or not. So each of those except blocks is only running if there was that error. The first time an error is found, it runs to the except. And then if finally is there, it runs that as well. And what would we do here? Well, here we would maybe close any open files. Maybe we would close a network connection if we had an issue there. Maybe we would do something else. Okay? The finally runs no matter what. It's completely optional, just like that else suite. So I run my code until I get an error. If I get an error, I skip to the appropriate except. I run it. If finally is there, I run it, and then I go to after my try block. If there are no errors, I run all my code, I go to my else if it exists, and then to my finally if it exists. Remember, being optional, you may not see the else or the finally. It just depends upon what your code is doing. Now, like I said, a lot of times with finally, that's where you're going to go in and close files or network connections, do any of that maintenance cleanup work. Remember what I said back in the file handling modules. Anything that you open, you want to close. So that gives us a good place to do that. But like I said, it's not always necessary, so you may not see it. But that's just a nice brief way of handling your exceptions or runtime errors that you might find in a program. Now, a word of caution or a word of wisdom I might want to provide for you. You want to make sure that you make it almost difficult, I'll put that in air quotes, for a user to make mistakes. That means make sure you give them good prompts so they know what to expect. Use error handling like we did with the while loop to make sure they provided valid and legitimate data. Use the correct or an expected type of data conversion. Think about, would this be a float or would this be an int? Am I converting this in a good manner? Think about those types of things to reduce your exceptions. Your exceptions are there to prevent rare problems, not common ones. Common ones you need to solve as you're developing the program. The best way to find those is by testing your application before you submit it to be either put out on the internet, submitted to be turned into your company so it can be put into production, or even turned in for a class. Just some things to think about as you're building your applications.